National Electrical Code Article 300.5. D3. Underground installations in the same trench with other utilities shall be constructed in accordance with the following. Minimum vertical separation of 12 inches or 305 mm. Minimum horizontal separation of 24 inches or 610 mm. Warning tape shall be installed above all buried utilities within the trench. Article 502.1. Electrical wiring shall not be laid in contact with any form of gas, water, or liquid or gas-type piping. Utility regulations. Many utility companies have specific regulations regarding the joint use of trenches by electrical wiring and plumbing. These regulations may vary depending on the local jurisdiction. Typically, utilities require a minimum vertical separation of 12 inches and a minimum horizontal separation of 24 inches between electrical wiring and plumbing. Warning tape or other suitable markers may also be required. Safety concerns. Water and electricity are incompatible. If electrical wiring comes into contact with water or plumbing pipes, it can create a shock hazard or an electrical fault. Plumbing repairs can be hazardous if electrical wiring is located too close to the plumbing. Workers may inadvertently damage the electrical wiring during the repair, creating a safety hazard. Recommendations. Firstly, maintain proper separation. Ensure that the electrical wiring and plumbing pipes are separated by at least 12 inches vertically and 24 inches horizontally. Secondly, use warning tape. Install warning tape above all buried utilities within the trench to alert workers to their presence. Thirdly, consult with the utility company. Contact the local utility company to determine any specific regulations regarding joint trench installations. Fourthly, consider rerouting or replacing. If possible, consider rerouting the electrical wiring or plumbing pipes to meet the required separation distances. Prioritize safety. Always prioritize safety when working with electrical wiring and plumbing. Ensure that proper precautions are taken to prevent accidents or injuries. Electrical safety is paramount when dealing with both wiring and plumbing in close proximity, particularly within a shared trench. The National Electrical Code, or NEC, provides specific guidelines to mitigate potential hazards. Article 300.5. D3 addresses underground installations in shared trenches, stipulating minimum separation distances between electrical wiring and other utilities such as plumbing. It mandates a vertical separation of at least 12 inches, equivalent to 305 mm, and a horizontal separation of at least 24 inches, equivalent to 610 mm. These distances are crucial for preventing direct contact and reducing the risk of electrical faults in the event of a water leak or other plumbing issue. Additionally, the NEC requires that warning tape be installed above all buried utilities within the trench. This tape serves as a visual indicator during excavation, alerting workers to the presence of buried lines and preventing accidental damage. This is a critical safety measure that can prevent serious injuries and costly repairs. Article 502.1 further emphasizes the importance of isolating electrical wiring from potential hazards. It explicitly states that electrical wiring should not be laid in contact with any form of gas, water, or liquid or gas-type piping. This provision aims to prevent corrosion, electrical shorts, and other problems that can arise from direct contact between wiring and pipes. Utility companies also have their own regulations regarding the joint use of trenches for electrical wiring and plumbing. These regulations can vary depending on the local jurisdiction, so it's essential to consult with the local utility company for specific requirements. Typically, utilities require the same minimum separation distances as the NEC, 12 inches vertically and 24 inches horizontally. They may also require the use of specific warning tape or other markers to identify the presence of buried utilities. One of the primary safety concerns with combining electrical wiring and plumbing in a shared trench is the inherent incompatibility of water and electricity. If electrical wiring comes into contact with water, it can create a shock hazard or an electrical fault. This can be especially dangerous for workers who are performing plumbing repairs or maintenance. Furthermore, plumbing repairs themselves can be hazardous if electrical wiring is located too close to the plumbing. Workers may inadvertently damage the electrical wiring during the repair, creating a safety hazard. This is why it's so important to maintain proper separation between electrical wiring and plumbing. Based on the NEC guidelines, utility regulations, and safety concerns, several recommendations can be made for safely managing electrical wiring and plumbing in shared trenches. The first and most important recommendation is to maintain proper separation. This means ensuring that the electrical wiring and plumbing pipes are separated by at least 12 inches vertically and 24 inches horizontally. This separation distance helps to prevent direct contact and reduces the risk of electrical faults in the event of a water leak or other plumbing issue. The second recommendation is to use warning tape. Install warning tape above all buried utilities within the trench to alert workers to their presence. The warning tape should be brightly colored and clearly labeled to indicate the presence of electrical wiring and plumbing. This visual indicator can help to prevent accidental damage during excavation or other work. The third recommendation is to consult with the utility company. Contact the local utility company to determine any specific regulations regarding joint trench installations. Utility companies may have additional requirements for separation distances, warning tape, or other safety measures. It's important to comply with these regulations to ensure the safety of workers and the public. The fourth recommendation is to consider rerouting or replacing the electrical wiring or plumbing pipes. If it's not possible to maintain the required separation distances, consider rerouting the electrical wiring or plumbing pipes to meet the requirements. This may involve digging a new trench or using alternative routing methods. In some cases, it may be necessary to replace the electrical wiring or plumbing pipes with materials that are more resistant to water or corrosion. Above all, prioritize safety when working with electrical wiring and plumbing. Ensure that proper precautions are taken to prevent accidents or injuries. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and using insulated tools. It also includes following lockout-tagout procedures to de-energize electrical circuits before working on them. By following these recommendations, you can safely manage electrical wiring and plumbing in shared trenches and prevent potential hazards. Remember, safety should always be the top priority when working with electricity and water. Now let us consider specific scenarios and delve deeper into the technical aspects of ensuring electrical safety near plumbing. Firstly, we will discuss the situation where existing electrical wiring is found in close proximity to plumbing pipes. In such cases, a thorough inspection is crucial. This inspection should assess the condition of the wiring insulation, the type of wiring used, and the proximity to any potential sources of moisture. If the wiring insulation is damaged or degraded, it should be replaced immediately. Similarly, if the wiring is not rated for wet locations, it should be replaced with appropriate wiring, such as Type UF cable, which is designed for direct burial in wet environments. Secondly, when dealing with metal plumbing pipes, it is essential to ensure that the pipes are properly grounded. Grounding helps to minimize the risk of electrical shock in the event of a fault. The grounding should be done in accordance with the NEC and local electrical codes. This typically involves connecting the metal plumbing pipes to the electrical grounding system using a grounding conductor of the appropriate size. Thirdly, consider the use of ground fault circuit interrupters, or GFCIs, in areas where electrical wiring is close to plumbing. GFCIs are designed to detect small imbalances in electrical current, which can indicate a ground fault. When a ground fault is detected, the GFCI will quickly trip the circuit, cutting off the flow of electricity and preventing electrical shock. GFCIs are particularly useful in bathrooms, kitchens, and other areas where water is present. Fourthly, when planning new installations of electrical wiring and plumbing, it is crucial to carefully consider the layout and separation distances. The NEC requires a minimum separation distance of 12 inches vertically and 24 inches horizontally between electrical wiring and plumbing pipes. These distances should be strictly adhered to. In addition, consider using physical barriers or conduits to provide additional protection for the wiring. Fifthly, when working with underground electrical wiring and plumbing, it is important to be aware of the potential for corrosion. Corrosion can damage both the wiring and the plumbing pipes, leading to electrical faults and water leaks. To prevent corrosion, use corrosion-resistant materials and coatings. For example, use copper wiring instead of aluminum wiring, and use plastic plumbing pipes instead of metal plumbing pipes. Also, consider using a protective coating on the wiring and pipes to provide an additional layer of protection. Sixthly, when installing warning tape above buried utilities, make sure that the tape is clearly labeled and easily visible. The tape should indicate the presence of both electrical wiring and plumbing pipes. This will help to prevent accidental damage during excavation or other work. Also, consider using different colored tape for different utilities. For example, use red tape for electrical wiring and blue tape for plumbing pipes. Seventhly, when working with electrical wiring and plumbing in a confined space such as a trench, it is important to take extra precautions. Ensure that the space is well ventilated and that there is adequate lighting. Also, use appropriate personal protective equipment such as gloves, safety glasses, and a hard hat. Be aware of the potential for electrical shock and water leaks, and take steps to prevent these hazards. Eighthly, regularly inspect electrical wiring and plumbing for signs of damage or deterioration. This includes checking for cracks, leaks, corrosion, and other problems. If any problems are found, they should be repaired immediately. Also, consider having a qualified electrician or plumber perform a professional inspection on a regular basis. Ninthly, when making repairs to electrical wiring or plumbing, always follow proper procedures. This includes energizing electrical circuits before working on them and shutting off the water supply before working on plumbing. Also, use appropriate tools and materials, and follow all applicable codes and regulations. Tenthly, when in doubt, consult with a qualified electrician or plumber. These professionals have the knowledge and experience to safely and effectively manage electrical wiring and plumbing. They can also help you to comply with all applicable codes and regulations. In addition to these specific scenarios, there are several general principles that should be followed when dealing with electrical wiring and plumbing. Always prioritize safety. Electrical shock and water leaks can be dangerous, so take all necessary precautions to prevent these hazards. Follow all applicable codes and regulations. The NEC and local electrical codes provide specific guidelines for electrical wiring and plumbing. Comply with these guidelines to ensure the safety of yourself and others. Use appropriate tools and materials. Use tools and materials that are designed for the specific task at hand. This will help to prevent accidents and ensure that the job is done correctly. Be aware of the potential for hazards. Electrical shock, water leaks, and corrosion can all be potential hazards when working with electrical wiring and plumbing. Be aware of these hazards and take steps to prevent them. Regularly inspect electrical wiring and plumbing. Regular inspections can help to identify potential problems before they become serious. If you are not qualified to work with electrical wiring or plumbing, hire a qualified professional. Electrical wiring and plumbing can be dangerous, so it is best to leave these tasks to the professionals. By following these principles, you can safely and effectively manage electrical wiring and plumbing. Remember, safety should always be the top priority when working with electricity and water. Now let's discuss the importance of proper grounding in more detail. Grounding is a critical safety measure that helps to protect people from electrical shock. It works by providing a low resistance path for electrical current to flow back to the source in the event of a fault. This low resistance path helps to trip the circuit breaker or fuse, cutting off the flow of electricity and preventing electrical shock. In order to be effective, grounding must be done properly. This includes using a grounding conductor of the appropriate size, connecting the grounding conductor to the grounding electrode system, and ensuring that all metal parts of the electrical system are properly bonded together. The grounding electrode system typically consists of a ground rod, a metal water pipe, or a concrete encased electrode. The grounding conductor must be connected to the grounding electrode system in a way that provides a reliable electrical connection. All metal parts of the electrical system, such as metal conduit, metal junction boxes, and metal equipment enclosures must be bonded together to ensure that they are at the same electrical potential. This helps to prevent voltage differences between different metal parts, which can create a shock hazard. In addition to grounding, it is also important to use ground fault circuit interrupters, or GFCIs, in areas where electrical wiring is close to plumbing. GFCIs are designed to detect small imbalances in electrical current, which can indicate a ground fault. When a ground fault is detected, the GFCI will quickly trip the circuit, cutting off the flow of electricity and preventing an electrical shock. GFCIs are particularly useful in bathrooms, kitchens, and other areas where water is present. They can also be used to protect outdoor electrical circuits. When installing GFCIs, it is important to follow the manufacturer's instructions carefully. GFCIs must be installed in accordance with the NEC and local electrical codes. They should be tested regularly to ensure that they are working properly. In addition to grounding and GFCIs, it is also important to use appropriate wiring methods when working with electrical wiring and plumbing. The NEC specifies different wiring methods for different applications. For example, Type NM cable is commonly used for interior wiring, while Type UF cable is used for direct burial and wet locations. It is important to use the correct wiring method for the specific application to ensure that the wiring is properly protected from the environment. When installing electrical wiring, it is important to follow the NEC guidelines for wire sizing, conduit fill, and other requirements. The NEC provides tables and calculations that can be used to determine the appropriate size of wire for a given application. It also specifies the maximum number of wires that can be installed in a conduit of a given size. Following these guidelines helps to ensure that the wiring is not overloaded and that it is properly protected from damage. Finally, it is important to regularly inspect electrical wiring and plumbing for signs of damage or deterioration. This includes checking for cracks, leaks, corrosion, and other problems. If any problems are found, they should be repaired immediately. Also, consider having a qualified electrician or plumber perform a professional inspection on a regular basis. By following these guidelines, you can safely and effectively manage electrical wiring and plumbing. Remember, safety should always be the top priority when working with electricity and water.